Algebra 2, Target 2. I can solve literal equations for a specified variable. Now, a literal equation is an equation that has more than one variable. So, for example, ax plus by equals c is a literal equation because it's all variables. Now, you're not always going to find all variables. You may have something put in for A, something put in for B, something put in for C, and you'd have, like, say, maybe 3x plus 2y equals 7. That's also a literal equation because there's an x and there's a y. The nice thing about solving literal equations and why we do it is because if we have this, say, solve for y, that gives us formulas. Literal equations are very nice for giving us formulas, so we don't have to resolve this equation. Or if we come up with another one, we don't have to solve that one. Or we can get another one. Right? All of these, if we solve this once for y, we can plug in A, B, and C and get that each of them solved for y using the literal equation when that's solved for y. A real famous example of a literal equation that you all love, ax squared plus bx plus c equals 0. That has been solved, and you get the quadratic formula. X equals negative b plus or minus the square root, b squared minus 4ac all over 2a. We're not going to look at that one today, but later this year we will look at how we solve this literal equation here to get the quadratic formula. But moving on, the equations, like I said in the examples, 2x plus 5 equals 11 and 6x plus 3 equals 15 have the general form ax plus b equals c. It's called literal because the coefficients and constants are all letters. It has more than one letter. So what we're going to do is we're going to solve ax plus b equals c for x. And then we're going to use that with the coefficients a, b, and c, which we replace with 2, 5, and 11, to solve this. Alright, so if I have ax plus b equals c and I want to solve it for x, I'm going to start, I'm going to see what's done to x. Right, a and b are replaced with numbers, so what would I do if a and b were a number? Well, first off, I would subtract the b. Okay, here b and minus b, that cancels off. We are left with ax equals, well, c minus b, I don't know what that is. That's okay, it's a literal equation. It's going to have a lot of variables there. So ax equals c minus b. And the last thing we'll do is we'll divide by a. X equals c minus b divided by a. Now on the surface, why don't we just solve this one right here? Well, maybe if there's only one equation, yeah, we'll solve that one equation. But really, we have two equations. We got 6x plus 3 equals 15 and 2x plus 5 equals 11. Now instead of solving each of those, we can just plug in the values. With 2x plus 5 equals 11, a is 2, so I'm going to plug in 2 for a. B is 5, so that'll be 5. And C is 11, so it'll be 11 minus 5 over 2, which is 6 over 2, so x equals 3. In this case, x equals 3. And you can do a quick plug and chug, substitute and evaluate to verify that x equals 3. 2 times 3 is 6, plus 5 is 11. Now, instead of solving this, we can just plug and chug. 6x plus 3 equals 15. Well, x equals c minus b. That's 15 minus 3 over 6. 15 minus 3 is 12. Over 6 is 2. So in that case, x equals 2. See how quick and easy that was once we solved the literal equation? And we can check when x is 2, 6 times 2 is 12. 12 plus 3 is 15. Just a little note, whenever you're dividing, you have to assume that that variable is not 0. Why? What would happen if a was 0? Well, first off, 0 times a would just cancel off. And second off, you can't divide by 0, right? So we know that a here cannot be 0, because you can't divide by 0. All right, solve the literal equation for x, then use the solution to solve the specific equation. Pause, try it, and then check your work. For number 1, a minus bx equals c, I'm going to subtract a from both sides. Negative bx equals c minus a. We'll divide by negative b. X equals c minus a over b. And in this equation right here, a is 12, b is 5. Keep in mind that that's a negative, so it's part of the equation. And c is negative 3. So x equals negative 3 minus a, which is 12, over b, which is 5. So that's negative 15 over 5. That's negative 3. All right, for number 2, I need to move the x's together. So I'm going to subtract bx from both sides. So I got ax minus bx equals c. This one's a little tricky. We got common terms there. They both have an x. So what I'm going to do is I'm going to factor it out. Some of you may be familiar with talking about it as reverse distribution. X is on the outside, a minus b, if we distributed x, would be what's got us on the inside. So x times a minus b equals c. Divide by a minus b. X is c over a minus b. And then we can go ahead and plug in. C is 20. A is 11. B is 6. 11 minus 6 is 5. 20 divided by 5, x is 4. All right, here's another application. You got a triangle. We all know the area of a triangle is 1/2 base times height. All right, let's solve that formula for h. And then if we know area and base, we can figure out what height is. All right, so solve the formula for h. A equals 1/2 base times height. I like to deal with the fractions first. I know a lot of kids your age are uncomfortable with fractions, so I'm going to get rid of the fractions by multiplying by the denominator. Multiply both sides by 2. We got 2a equals 1/2 of 2, multiply the numbers together. They cancel off. 2a equals base times height. And we're solving for height, so we'll divide by base. The height of the triangle is twice the area divided by the base. Now, if we know the area of this triangle is 64.4, height equals twice 64.4 divided by 14. You can break out your calculators for this one. Two times 64.4 divided by 14. The height of this triangle is 9.2, and this is an application, so make sure you label it with units, 9.2 meters. More guided practice. Solve these, pause it, solve these, and see how you do. We'll start with number 3, solve for y. 5x plus 4y equals 20. We'll subtract 5x. 4y equals 20 minus 5x. Divide by 4. Divide each piece by 4. Y equals 20 divided by 4 is 5 minus 5/4 x. Right? And that gives us slope-intercept form. We've solved that literal equation. For number 4, The perimeter is given by the formula P equals 2L plus 2W. Solve the formula for W. All right, we'll start. If we're solving by W, we'll get rid of the 2L. So 2W equals P minus 2L. I don't know what that is. It's a literal equation, so we just need to write it literally, as you see it, P minus 2L. Divide by 2. You can divide in P, so you can divide the whole thing. W equals P minus 2L over 2. And in this rectangle, our perimeter is 19.2. Our length is 7.2. We can use our formula to figure out what the width would be. 19.2 minus 7.2 times 2 divided by 2. Let me write in the times 2 here. Divided by 2, the width would be 2.4 feet. And if you're not certain, plug that into the original literal equation. All right, take 2 times 7.2 plus 2 times 2.4. You should get 19.2. And we do. All right. Okay, finally, a very famous equation, which we like to go back and forth, is the Celsius-Fahrenheit equation. Here is Celsius in terms of Fahrenheit. So if you know the Fahrenheit temperature, you can convert to Celsius. Well, it's always nice to be able to go the other way. So maybe you know Fahrenheit, you want to get to Celsius. Instead of plugging it in every time and resolving it, just go and solve it literally. So you start, we'll deal with the fraction here. Take the 5/9, multiply both sides by 9/5, the reciprocal. It cancels here. You get 9/5, C equals F minus 32, and add 32. And here's our literal equation to convert Celsius to Fahrenheit. So in review, a literal equation is an equation with more than one variable. And you can solve it and come up with formulas. For example, ax squared plus bx plus c is a literal equation, which long ago someone solved and came up with the quadratic formula.